All right. Good morning. Welcome to Montreal. Welcome to CATS. If you didn't want to be in CATS, then now is your chance to escape. There are exits there and there. I'm Adrian Farrell, and our co-chair is Peng Liu. Peng is in China. And we'll run the first set of slides about the meeting. Go ahead, Peng.
Okay, thanks, Adrian. Good morning, everyone. So we can go to the next slides. So here's a notewell for each meeting, just to remind that you agree to follow IETF process and the policies. And all the participants are expected to behave in a professional manner and extend respect and courtesy to your colleagues at all times. And if you have any concerns about the behavior, please contact the BIS team. And if you are aware that any IETF contribution is covered by patent or patent applications, you must disclose the fact or not participant in the discussion. Please note that we have two drafts under the IPR disclosure asking. And the audio-video records of meeting may be made public. And personal information that you provide to the IETF will be handled in accordance with the privacy statement. And more details could be found at the upstairs list here. So this is about the issue of harassment. Um, the same with the last slide. If you have any concerns about the observed behavior, please talk to the AMBIS team, who are available if you need confidentially to raise concerns confident about it or other conduct in the IETF. For all the on-site and remote participants, make sure to sign into the session via data tracker or the QR code in the session, including join the queue and the show of hands. Remind to keep audio and video off if not using the if you are not speaking, and please help to take minutes here to make sure that your comments are recorded correctly, which could be a good reference to the next steps of your work. And here's agenda of this meeting. We have relatively small slots of the working group document since the use case and framework are going to be stable. And there are the IPR disclosure of both of the two documents and the last call on the use case one. And for the metrics, we hope any of you could provide more useful comments. So we have 8 individual draft presentations here. Some of them fit good to the charter, where some may need more clarification about it. And we are starting to discuss about the solution suggestion, but please note that the protocol extensions must be done in the working group that owns the protocol, unless the working group sends the work to CATS. And presentations here don't imply any support for a specific protocol extension, but the analysis work could be done here to help to build a CAS system. And any comments on the agenda? Okay, here's the working group document status. Please reply to the IPR and the last call on the two documents. And for the milestones, we are going to catch submitting the framework document to the IESG for publication as informational. And here again, for the individual draft, pay attention to the chart text. For instance, the additional groundwork and the applicability existing tools and mechanisms is also good. So here's about the chair slides here. We are now hand over to Adrian to run the agenda. Thank you.
Yeah, thank you. So I'm just looking at the list of participants in Meet Echo, and I'm going to guess that about half of you here haven't yet joined Meet Echo using either the full tool or the light tool. Please do that. That's really important for the blue sheets, and actually it's important for IPR reasons as well. Right. So first up is going to be Kihan, and I'm going to give you control just as soon as I can find you. There you are.
And hi, Agent, can you hear me?
Yes, all good. And you should now have control of the slides.
Thank you so much. So, yeah, so I want to quickly introduce the overall update of the use cases and requirements working group document. So, as suggested, I only, summarize most of the updates in this single slide. So, because it is being undertaken the working group last call, and so here are the basic updates since the last meeting. Primarily, we have some reflection on the Shepherd's review from Daniel Huang, and also we have reached consensus with Carlos on adding a new potential use case with and also its corresponding requirements on ISAC, named that integrated sensing and communication in Appendix B, because we see there is some potential work for CAS to do uh, in the future work. And also we received some valuable comments from Iran Welling in the IETF 1 to 3 in Madrid on CAS extensibility. So we add a new requirement into the document. Please see the difference file. And also we had add a small discussion part in the latest subsection in the use cases and to refer to some ongoing work in other SDOs. For example, to refer to work in EDSI in 3GPP to show relevance with work in IETF. And also then we had add some new contributors and also update the acknowledgement. So these are most of the updates since the last meeting. And the current version, namely the number eighth version, is being undertaken the working group last call. So if you have any suggestions or further comments, please feel free to raise in the working group list. And also, if you have other like IPR issues, please also raise as soon as possible. Thank you all.
Thank you, Kihan. This is a great test for the AV guy. Right, hopefully you can now hear me in the room. Yeah, thank you. The last call on this document runs until the 18th, but obviously sooner is better for comments. Also, at the same time, we're doing the IPR poll, and I'm still missing responses from, I think, 3 contributors. So if the authors could chase up their friends to make sure we get those, because the last call will not complete until we've got all that, all those IPR responses.
Okay, already contacted with them. Yeah, thank you.
Thanks. Okay, next up then the framework slides.
Hello, Chengli here.
Hi, Chong. You've got control of the slides.
Okay, thank you. So I'll introduce the update of the CAS framework very quickly. So basically, we have two parts here. The first one is the changes since the last IETF meeting, and then what is the next step is the second part. Yeah. So after the previous IETF meeting, we basically made, 6 revisions to address the comment from Xiongquan, Taylor, Zhongpeng, Giuseppe, and Adrian. Yeah, so many thanks to their valuable comments and reviews, right? And mainly we update the draft to address the comment regarding, terminology, uh, uh, and passive voice and metric distribution and some errors or bugs in the example illustration, and to clarify the whole cast environment is for a single network provider. So that is kind of clarification uh, update. Yep. So recently we received the comments from agent about the CAT framework draft. Uh, so we basically have two parts of the comments. One is the major issues, and wow, something wrong here because we cannot see the whole content of the slides. Anyway, yeah. So for the major issues, mainly about the CNMS, like do we have any scalability consideration of collecting and distributing the per service instance metrics? The answer would be yes. The metric, the per service instance metric need to be aggregated before distributing to the network. And the second question is about the hybrid distribute mode. Do we have multiple CPS? The answer is no. We only have only one CPS. And for the control, centralized control plan, we make the clarification to modify the term to centralized control element. Yeah. And for the components from different vendors, we emphasize that the normalization function has to be the same. Yeah. And also we restructured the content by moving the examples of metric distribution to the appendix. This was the a suggestion from Matt, so we think it's a good idea. Yeah. And for some minor issues, you cannot see in the slide because they are quite minor. I would say, just a joke. But anyway, we have addressed the minor issues here, so don't worry about that. But we're still waiting for the confirmation from agents. So please, Chair, if you have free time this week or in the future, we are waiting for your confirmation. Yep. And yeah, so this is just all for the part one. The part two is very simple. We think it's ready for the working group last call. So yeah, we request for the working group last call again. Yep, thank you. That's all. Thank you.
Yeah, so thank you, Chong. You just posted the dash 18
Yes.
revision, and you believe that addresses all of my review comments, yes?
I guess 90%, maybe. Let's check.
Yeah,
The 10%.
yeah. Obviously, I'll do the check. But
Yeah.
you believe that you've got everything captured, or at least all the major ones.
Yep.
So I will be checking that later this week, and the chair's plan to start a working group last call almost immediately, so that will complete within November as well.
Excellent.
Same issue as with the use cases, a couple of IPR disclosures still missing. So if you
really?
I'll drop you a note to say who's missing.
Okay,
and
okay.
You can chase them. Brilliant. Thank you.
No problem. I saw all of the contributors and all the have replied to the IPR call. But anyway, let me know. Yep. Anytime.
Okay, seems to be quiet in the room, so we will move on to the metrics draft. And in a shock for everybody, we've actually got a presenter in the room.
Thanks, Adrian. Yeah, this is Jordi from Qualcomm, and just representing here the group that we're working on the CATS metrics draft. And thank you. Yeah. So I'll just go through here the high-level updates, and then I'll dig into a couple of these items more closely. But overall, these are the changes since the last revision. First, we kind of proactively changed the status of the document from informational to standard track. This is something that at the end I'll ask to see people agree with that. We updated also section 3 design principles. We now include a new level 1 service class, which we call level 1 metric class, which we call the service type. This was also coming from the previous IETF 123 discussions, and there seems to be a general agreement on this. Updates in section 4, we changed the name of that section to be CATS metrics framework and specification. We also introduced the concepts of normalization and aggregation functions in section 4.2, which had been discussed before, but now we have them more formally defined in the document. We added a statement on the meaning of the scores in section 4.3 to clarify some of the questions also that were brought up in the past. We updated section 5 with minor changes in table 1. This is just mostly changing the adjectives that we use in that table, so minor changes. And then we moved to Appendix A level 0 metrics examples that were before in the main body of the document, because we're not going to be standardizing level 0 metrics, so we just push them to the appendix as examples. Okay, just I'm going to dig into a couple of these items, just at the high level. So, normalization and aggregation functions. This is something we have added to the document. So these are fundamental functions that allow us to transform raw metrics and derived metrics into forms of suitable metrics for decision making. What are they really? So you can think of them as aggregation functions. The input is you have multiple metrics, and you like to consolidate them into a single metric. So that's what an aggregation function would do for you. Examples of aggregation function is the mean average, min max, or weighted average. So that's a component that allows us to consolidate, say, for instance, multiple level 0 metrics into a single level 1 metrics, and also multiple level 1 metrics into a single level 2 metrics. The other direction on this is normalization functions, which is about taking a single metric which could be with units or unitless, and convert it into a unitless metric. So it's basically what we call normally known as normalization. And so examples here could be a sigmoid function, min max scaling, z-score normalization. The idea behind this is that you might get some input metrics that have certain units, like latency could be microseconds, or CPU could be megahertz. And then you just want to come up with a metric that is unitless, that provides a score, maybe a score from 1 to 5 or from 1 to 10. So that's what we call a normalization function. And the idea is that by applying aggregation functions and normalization functions, you should be able to pretty much compose metrics in a general way and kind of accommodate for hopefully the important use case or that we want to deal with. We've clarified also the meaning of a scores. So what does a score mean? This can be quite challenging because, especially in the context of heterogeneous environments like at the edge, dealing with multiple implementations, how to compare unitless scores is non-trivial. So here the node we add into the document is a node for the implementers and a node for the operators. For the implementers, of CATS metrics should provide clear and precise definitions of what their metrics is. The better that they describe this, these metrics and what they really mean, especially for the for the unitless metrics, the better. And for operators, should exercise caution when making potentially impactful decisions based on unitless metrics, whose definitions are unclear or under-specified. So we just want to bring awareness about the challenge of operating in heterogeneous environment and getting agreement on what a metric really is. Now, topics for discussion and feedback that we seek. So due to the nature of this document, a standardization of CATS metrics, we're proposing to change it from informational to standards track. And secondly, based on previous feedback, we're working under the assumption that this document should not standardize level 0 metrics, but it should standardize level 1 and level 2 metrics, which is going to get some kind of confirmation for both of these questions. And just to conclude the next steps, facilitate discussions over the issues in the mailing list. So, and then for the next IETF, we have a milestone to submit to the ISG for publication of the document. So this, I think this next 3 months will be very important for this document. Yeah, feel free to add comments and contribute.
Thank you. Greg, you're up.
Greg Mirsky Erickson. Thank you for this work. So I have a couple of questions. If this document is a standard, in your opinion, do you define new metrics, new performance metrics?
Yeah, it's related to the second question. So yeah, we don't plan to define level 0 metrics, but the plan is to define level 1 classes of metrics. So we have right now 3 or 4 classes of metrics: compute, communication, and service metrics, and composition metrics also. So that there's intention to actually define that. And then there's a question of whether we want to go one step further and actually standardize, write additional templates for these metrics and what structure they should follow. Yeah, but for sure, the level 1 metrics classes is what this document will be specifying. Yeah.
Okay. In that case, I think that you should follow their RFC 8911 and add these metrics to IANA performance metrics registry. So if these are new metrics, also what would be probably helpful if you reference the existing metrics in this registry as they're used in your document. That's one recommendation. Another question I have, so yes, you pointed out that instant reaction to the change in performance metrics may lead to adverse behavior in the network because the metrics might change really fast. So you might look at performance availability, precision availability metrics that adds this capacity of hysteresis. So basically, you look at different metrics as their stability characteristic, so that operators might get a better understanding of trends in the behavior.
Yeah.
And I know that Louis is well aware of this work because he's developing some additional, extending this paradigm that's been developed in IPPM working group.
I think you make a good point, Greg, about IPPM. And although this work is not really overlapping with IPPM, I would think that IPPM has got a lot that it can offer us in terms of how we think about metrics.
I absolutely agree with you.
Cool. Okay, we'll make sure they're in
definitely there will be a good thing for collaborating and liaising this work and bringing to attention of IPPM, because IPPM is IP performance metrics, and have been a recognized center of competence at IETF at least, and elsewhere in developing performance metrics. And here it's clearly looks like performance metrics might be of different scale and different level.
Good, thank you. John.
Yeah, Chun-Li from Huawei. So I would say we should pay more attention to this draft after the use case and framework document passed the working group last call. Now we haven't got enough attention to this draft, no matter for the mailing list discussion or other required or invited review. We do not have enough comments yet, so we might pay more attention to it, and I will work on it after the framework draft. Yep, that's it. Thank you.
Yeah, thanks. I couldn't agree more. Let me do a quick poll just because, hey, I can. So the question here is about the intended status for this document, and are you okay moving this to standards track? This is obviously not consensus forming, but it's indicative for the chairs. So
It's not going to be my vote.
okay, this is looking good and helpful. If the person who said no wants to come to the microphone and say why they're unhappy, then that would be great, or they can talk on the list or talk to the chairs privately. Okay, I think. You're the no. Do you want to say anything? Yeah.
Thank you. Aram Welling. So, yeah, I just want to express that I want to see the latest versions. That's the reason it's no. I always say no first until all the I's are dotted and T's are crossed, that we understand what's going on here. I raised some concerns last time, and I saw that they've been addressed, but I need to see if they're fully addressed.
Okay, good.
Thank
No,
you so
that's clear. Thank you.
Thank you. The other thing I would like to raise, I was going to raise my hand anyways, is perhaps it's covered in the documents. The integration with non-CATS environments. Is that fully addressed in the documents?
Sorry, what is it again? The
integration with the non-CATS environments?
integration with the
Non-CATS, with the environment that is not CATS.
not CATS. No, the document does not address that currently. So it just focuses on CATS. Yeah.
Okay, thank you.
Yeah. Thanks.
Kihan, you're back in the queue, yes?
Hi, Agent. I just want to answer the question from Iram that I think you have raised the requirement on the extensibility of CAS in non-CAS working environment for the use cases document. I think I have replied you in the use cases requirement, the document. I have added a should requirement in that document. Please refer to the use cases document for the difference, not in this matrix draft. Thank you.
Okay, thanks.
Thank you very much.
All right, now we're moving on to individual drafts and around the solution space. And I want to echo the point that Pong made up front, which is that we're not chartered to do protocol solutions work, but we are chartered to look at the requirements on protocol solutions and coordinate with the working groups that do work on protocols. So just be careful about assuming that anything will get developed here. Chan, I don't see you. Ah, there you are. Turning up.
Hi, Ethan. Hi, good morning. Can you hear me?
Yep, that's all good. And I've just given you control of the slides. Off you go.
Okay. This is Ranjong from VT. Good morning, everyone. I will present the data model for CAT on behalf of the authors. Yeah, this document has been presented at last meeting, and thank you for the comments from Adrian and On. And this is the update from version 3 to version 4. We revised the section 2.3 and the bigger one to align with the framework document, and such as the display, control plane, CSMA, and CPS. And we also added definitions for CCIB and CNIB. We also revised the CAT-YARN attributes to align with the terminologies divided in framework and metric. We also make actuarial revision and context descriptions. We also welcome the new co-author. So this page shows the main update for the CAD system architecture. We update the overview of the CAD system architecture to align with framework architecture. For example, revised the functional components terminologies such as the data plane, control plane, CSMA, and CPS. And we also add definitions for CIB and CNIB. CIB is used to maintain the CAS network computing information and provides the basic data for CNMA. And the CNIB is defined maintaining the CAS network information and provide basic data for C and NMA. We also defined the CAS and SBI and CSMA API interface. From this update, we updated the terminology. For example, we defined the CAS SBI to report some computing information from the task orders to the control plane. We also to send pass and service policy information from the control plane to the task orders. And for the CSMA API, it is an extended interface between the control plane or management plane and the CSMA or between the task orders and the service instance. So it also can be used to report service metric information to the control plane to CAS from the control plane to the CAS forwarders. So this is a main update for the whole system architecture. And for the YARN model structure, we revised the CAT-YARN attributes to align with the terminology defined in framework and metric. For example, the control plane or the CIID. For example, we defined CAT-YARN, and it can be divided into control plane YARN, 4D plane YARN, and notify YARN. And the following pages, we have described the YARN model structures, but we have described them in last meeting, so I will recap them quickly. For example, for the CAS-based configuration tree, we just revised the control plane, the terminology from the to the control plane and the CSMA. We define the interfaces between the control plane and the CAS forwarder. So last slide, it is the same with last one. For CAS traffic classified file tree, we just revised the control plane terminology. And it is the same with the CAS service metric tree. We revised the control plane, the CSMA, and the CSBID. So it is the same with the cast forwarding packet. We revise the control plane and the CSCI. Yeah, last one, the load tree, we also revise the control plane to align with the terminology. So last step, we always appreciate the further review and the feedback, and the authors requested for CAS working group to consider the adoption of this draft if you consider that it is ready for the CAS young model. Thank you.
So thank you. I think the chairs believe that there's something useful here that the working group should be looking at. So we are inclined to look at adopting this. As we do that, I think there will be two chief questions for the working group. One will be, do we need Yang models for this work? And the second would be, is this the right starting point? Assuming that many changes will get done as the solution space develops. Joel.
Joel Halpern with Ericsson. I am a little concerned by this draft in both of the regards you mentioned. So if we think about the control information distribution, we're going to define a general framework, and then somebody will define a protocol for distributing the information. That, depending on what the protocol is, you might or might not need an additional Yang model for that, but we don't know yet because we don't have a protocol. I also noticed that the proposal has forwarding plane stuff in it. And we have specifically said that the process of taking the metrics and deciding how to forward traffic, both in terms of where to send it and how to encapsulate it, is a local matter. This means that almost anything you can do is legal. Very hard to define a Yang model for local behavior other than by the vendor. So I'm a little concerned that defining that constrains what people can do in ways that are maybe, not are, but may be inappropriate.
Yeah, thank you. Okay, we will take that on board in as chairs to see whether there's something that can be refined out of this document before talking about adoption. All right, good. Now I have to do some clever flying here. Just for the record, that was 12 mouse clicks to change the slide deck. Right, so you're still going, Chan, with the OEM document.
Yeah, thank you, Adrian. I will also present the CAS OEM on behalf of the authors. Yeah, this is the first time to present it in CAS working group, so I will first describe the motivation. As we will know that in the CAS framework, the CPS collects surface metrics from the CSMA and the network metrics from the CNMA, and to select the egress CAS forwarder or acting as service contract instance. So we and in CAS charter we also mentioned that we need to consider some OEM topic. So, for example, to provide the adequate OEM for CAS, the following issues may need to be addressed. For example, first one, the CAS may provide the submetric monitoring or and failure detection from the CAS forwarder to the service instance. The CAS forwarder 2 is the egress CAS forwarder and to the service instances. This is the loop for the routing error. And the second, the case may vary wide for the CPS that is selected network, and the computer paths may satisfy the SLA, and from the case forwarder, the ingress the case forwarder to the third instance. And the third is the case may continuously measure the flow performance and the reroutes for switch the process to keep the established sessions with the SLA guarantees. Last one the case may provide some fast end-to-end fault localization detection or some troubleshooting for client services. So this is the motivation for the CAS services for the OOM. So for based on the consideration, we may consider some OM layering model for the CAS. For example, the link OM, it may be conducted for a single link for the failure detection and performance monitoring. And in CAS OM, the link OM should cover the link from the egress CAS forward to the substance. And for Turner OM, the Turner may bear multiple CAS surfaces, and the failure detection or the performance monitoring are conducted on the ASP layer. And in CAS OM, a Turner OM may cover the lateral paths from the ingress CAS forwarder to the egress CAS forwarder. And for service OM, it may be on the sub-layer and provide the network to evaluate service quality. So in CAS OM, the service OM should cover the part of the service instance. So we also sorry. Sorry. So we also discuss some SOM functional components. For example, we may define some service instance OM to factor the failures and measures the service metrics between the egress CAS border and service instance, and have some feedback to the CSMA for quick failure detection. And we may also to consider the traffic classifier OM to monitor the paths of the ingress CAS forward to the service instance to ensure the SLA. And we also may see the trigger recalculation for the SLA is not met. And the last that for the flow OM may access and the performance CAS and may suggest paths dynamically for the user experience. So finally, based on the framework, we may consider to provide some customary requirements for the operation, administration, and maintenance. For example, for the operation, we may provide some sub-second telemetry utilization. For example, the CPU, GPU utilization, and the average, and for the network metrics. If we also need to consider the compute resource provisioning. The load will advertise the compute capability. The OM will authenticate and seams into the network. And we also may require the subsequent and the billing multi-factor billing model will to the end network. And for maintenance, we need to consider to provide end-to-end quality. For example, it may no more than 50%, for 50 milliseconds in network, and we may provide second-level compute libraries. And we need to consider the fault localization and self-healing. So this OM work does not protocol changes currently in this document. It is just a framework to establish how OM works in CATS and might be used to drive other work. So the authors want to make sure if this work is interested to CATS working group and appreciate more review and feedback. Thank you.
Thank you. I, for one, am really pleased to see you looking at the OEM and manageability issues around CATS this early in the cycle. Too often it's left really late. And maybe you should be looking at this to drive the motivation of the Yang model that you previously talked about. Let me use this as an opportunity to advertise 5706 BIS, which is a document talking about operational requirements on protocols that's being discussed in the Ops Area Working Group, and maybe you'd like to look at that as a bit of context. Let me see, we have Chong Li in the queue.
Yeah, so I suggest you to send an email to the mailing list to request for more review and feedback, because this draft has been, proposed for a long time, but I don't see any discussion of this draft. Yeah, if you want to move it forward, yep, you should get more consensus. Yep, thank you.
Yeah, I actually see this document as needing to be there in the background for quite a long time to help shape the way we think about the architecture and the solutions. Erin.
Sorry, next time I'll just stand up here so I don't have to wait for that. Anyways, thank you for presenting this. I do have a question about the O&M aspects of measuring the overhead that comes with CATS. So is there a consideration for us to gauge what is the cost of doing CATS from a technical throughput management standpoint? I'll start with that and based on the response. Thanks.
Yeah, thank you. I think the measuring from the CAS forwarder, ingress for CAS forwarder to the egress CAS forwarder is the existing technology, but in CAS service we have add some parts of from the CAS egress CAS forwarder to the service instance. So we may consider to provide some measuring of the service metric or compute metric for the CAS service. So do you have any suggestions for how to measure, or we just provide the requirements, and currently we don't consider some technology extension now?
Thank you. Yeah, I was thinking in terms of, as part of the decision of at a high level, whether to use CATS or not, we need to usually you do some kind of benchmarking of one solution versus another, and then you could do. So I was wondering if there's already consideration for somehow measuring. You reference SLAs here. What are the SLAs for CATS? Because there is, when you're doing all this awareness and decision making on the fly in a very, very dynamic environment, there's going to be considerable overhead associated with that. So, how do we measure that? Is what I was getting to. Thank you very much. I don't have a suggestion at this time. I would have to read the details. Thank you so much.
Okay, good. Thank you. And next up will be Linda. All right, you should have control of the slides if we're lucky.
Okay, let me try. Okay, good morning. Thank you for giving me this opportunity to give an update of 5G Edge metadata progress in the IDR working group. This document has been very stable, is waiting in the queue for the working group last call. So this edge metadata pass attribute in IDR is defined as optional non-transitive BGP pass attribute to carry matrix and metadata about edge services attached. So non-transitive, it means if a receiver, the peer recognize it, it can use for local decision so that when the routers in the edge data center attach them metadata for the ingress nodes to use to compute the path to not only based on network cost, but also the service matrix. If the receiving node, the ingress node recognize it, they can use it, but it's not, it should not advertise further to other peers. If the ingress nodes don't recognize it, they should drop it. But all the other update, all the other BGP path attributes have to be processed as normal. The BGP session should not be terminated because of a receiving node not recognizing the path attributes. Another thing emphasized in the document is for the 5G environment, there are only a subset of routes that require to compute the path based on the service metadata and the network path. Some traffic don't need to, like for example, for the user device browsing internet, those kind of traffic don't need to consider the edge data center's environment. It is a local configuration. On the right, you can see a typical example of BGP update. Is a path attribute together with all the other path attributes BGP have specified. IANA has assigned a new type code 42. So that is the brief of this particular metadata path attribute. The most important thing being discussed in IDR is about limited domain, because matrix reflect a lot of local environment of edge data center. It is not appropriate for security reasons to be propagated outside the limited domain. So therefore, quite a few mechanisms put into place just to prevent those metadata being leaked into unintended nodes. So first one is when the BGP open message, there's a new capability code 78 being assigned by IANA to negotiate the metadata support. So the metadata support can be two types. One can be like ingress node can indicate that I support everything, all the metadata for all the routes attached, all the routes received. There could be another indicator that ingress node indicating I only support metadata for specific FE-SAFI. So with that, you attach the supported FE-SAFI so that for other FE-SAFIs supported by this nodes, the metadata would now be propagated. There are three mechanisms being put into place in this is one is non-advertised community, so that nodes can add a non-advertised community so that receiving nodes know that this will not be propagated. Another way is adding an AS scope sub-TLV, basically indicating that for this particular deployment, we may support a list of ASs, and the metadata is only valid in list of those ASs. And another way is the route filtering and the policy that can also limit the propagation of the metadata.
Linda, I'm just going to interrupt you to say we have wonderful audio and that's working fine, but it looks like the IETF network has gone down, so we're missing all sorts of bits and pieces. But keep talking, we can see you, we can hear you.
Oh, you can. Okay, good, good. Okay. Limited domain provisioning. Limited domain is by provisioning, and basically it consists of the edge site. Like in the 5G environment, you have edge data centers, you have UPFs, and all those form the limited domain. And the router in the limited domain are provisioned with the policy to ensure the traffic is routed based on both traditional BGP attributes and the service-specific metadata. The policy must be consistent across the domain to ensure the predictable behavior. When the limited domain span multiple ASs, the inter-AS policy must be coordinated to ensure that routing behavior remains consistent. Here is just rehash of more details on the non-transitive and how the RR can append this non-advertised well-known community to the update. And there's a new, there's a AS scope sub-TLV, which lists down all the ASs which are in the scope for the specific metadata propagation. And here are some of the past edge, the metadata being specified by BGP, by IDR working group. I know CAT's working group have defined very comprehensive set of matrix and have different levels and structures. And here in IDR, in this 5G metadata, we have some preliminary matrix being specified. It's mainly to show those are the possible ways to attach to a service. So a simple one is the site preferences. For different services, different data center may have different level of preferences. It's really just a value. It's an abstract value, normalized value. Can be based on the power, bandwidth, or storage, or other attributes. Another one is the site physical availability index. This is really reflecting for edge data center that where there could be the physical failure impacting hundreds of routes, like power failure to a pod, a power failure to a rack, a server rack. There could be hundreds of services impacted. Instead of edge and router sending out hundreds of route withdrawal, we attach just one single message. So for all the routes associated with this particular site ID are failed, so that the ingress node can take all those routes, taking as they receive the route withdrawal. With that, basically for the route advertisement, there's a site index attached to the routes. And whenever failure occur, there could be a standalone message indicating all the routes associated with site failed. Another one is the service delay prediction and service-oriented capability. Those are very similar to what CAS have defined. It's really an abstract value. So those are some of the matrix being defined by in IDR. So in IDR is more about the path selection. So I think I don't have much time left. There are many different ways in route selection, handling the priorities of BGP traditional matrix versus combining with the metadata. So there's also like different scenarios being described in the document, showing that traditional BGP attributes priority versus metadata value priority, how to combine them together. So, and here are the IANA registration we have mentioned before, so I don't have to go through that. Okay, well, thank you. My time is up. So any questions, please either ask here or send emails on the mailing list to IDR. Thank you.
Thank you, Linda, and apologies to you and everybody for the interesting failures in the room. Those of you in the room who want to actually see the slides as they're going along, if you actually join the meet echo with a full client and remember to mute your speakers and your microphone, then you can actually see what's happening. Yeah, so Linda, I think what we need to do with your draft is look a bit more carefully at the applicability to cats and also the non-applicability.
Yeah.
So we need to look at, well, what would happen if cats was trying to run on a multi-AS system, and what would happen if we had a lot of dynamic metrics that we needed to distribute, and would your approach be appropriate? For that sort of covers what might not be applicable, but then we can also look at the ways that it would be applicable, especially for capabilities and things like that. So I think that's a piece of work we can do going forward, and it's not necessarily something that goes in your draft. It might be that you write a separate, very short draft saying the applicability of the 5G edge metadata to cats.
That's a good suggestion. Okay, will do. Okay. Okay.
Thanks.
Thank you. Okay.
So for time, we will move on. Right. Yeah, let me just find the slides. Do come up to the front. I can't locate. That's actually coming from somewhere in the roof. Good. We'll send an AD to find out if we're dying or not. It does sound a little bit like a fire alarm.
Attention, attention. Un signal d'alerte nous a été transmis. Nous en cherchons actuellement la cause. Veuillez attendre les instructions suivantes. Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions.
Standing by. Well, I've never had this happen to me before. This is quite fun. I did, yeah. So we're standing by, whatever that means. In the meantime, if you can all stand it without your autism triggers going off. Meng Yao, do you want to try over the top of this?
Attention, attention. Un signal d'alerte nous a été transmis. Nous en cherchons actuellement la cause. Veuillez attendre les instructions suivantes. Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions.
It's going to get quite annoying, isn't it? Is there nothing that can be done in IPPM to fix this, Greg? It sounds like an alarm. Surely there's a.
Attention, attention. Un signal d'alerte nous a été transmis. cherchons actuellement la cause. Veuillez attendre les instructions qui suivront. Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions.
Yeah, I don't know. I think this is pretty much impossible to
Maybe let me
concentrate.
try. Okay.
See how it goes.
Okay. Hello, everyone. Yeah, it's a voice. My name is Meng Yao from China.com, and my topic is the distribution of service metadata in BGP flows specification. And there are two co-authors, Xixi from China.com and Cheng from Huawei. And here is two, our draft name is also from Ideas Group. And why we come here is we try to distribute the service metadata because it can enable the CAS, the computing metric traffic steering. So
No, I think let's take a break while this is happening, and we'll continue. And if we need to use the little gap between the meetings, then I will cheerfully do that. But yeah, this I can't.
Okay.
All right. All do your emails.
Very interesting. Good luck, guys.
Cherchons actuellement la cause. Veuillez attendre les instructions qui suivront. Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions.
That's why alarm filtering is important.
Yeah. On the positive side, the projectors have rebooted.
Attention, attention. Un signal d'alerte nous a été transmis. Nous en cherchons actuellement la cause. Veuillez attendre les instructions qui suivront. Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions. Attention, attention. Un signal d'alerte nous a été transmis. Nous en cherchons actuellement la cause. Veuillez attendre les instructions qui suivront. Attention, attention. Another signal has been received. We are now investigating the cause. Please stand by for further instructions.
It's worse when it stops.
Oh. Okay.
Okay, this does appear to have really stopped. Yeah.
Let me try again.
And that should work.
Okay, let me continue my presentation. Okay. So according to the CATS mail list, there are we focus three problems, and these CATS care about. The first one is what is the distributed model, And there are two types. It's a centralized and distributed model. Each have the trade-offs in the scalability and complexity. And next is what the protocols are suggested. We need to consider the protocol extension capacity. So such as the use of BGP need to extend to carry the metadata, but this must minimize the deployment overhead and maintain the backward capability. And the third one is what information would be distributed. Information form selection. There are two options. First one is raw metadata, such as the per instance metrics or the aggregated values, such as averages value can be used. So the former one, the raw data offers a precision, but increase the overhead, while the aggregation can reduce the granularity, but also can reduce the overhead. Next slide. So let's show our solution or view of the centralized distribution model. There is a figure to show use a very simple and less costly way to aware the computing information. And there are three steps, including the collection, processing, and distribution. For the one, the BGPRS is used to collect the stories, metadata, such as the load capacity from edge sites and the network topology from underlying devices. And then we can process it, do the conversion by the controllers, can compute the optimal path based on the combined network and computing metrics. And then we can do the distribution. I can use the BGP extension to carry the metadata and the path policies to the ingress cats folders. And there are three advertisements. The first.
Thank you for your cooperation. It is now possible to return to your working area.
We need to wait a moment or continue.
Attention, attention. Our investigation reveals that no emergency situation exists. Thank you for your cooperation. It is now possible to return to your working area. Attention, attention. Nos recherches indiquent qu'il n'y a pas de situation d'urgence. Merci de votre collaboration. Vous pouvez maintenant retourner à vos postes de travail. Attention, attention. Our investigation reveals that no emergency situation exists. Thank you for your cooperation. It is now possible to return to your working areas. Attention, attention. Nos recherches indiquent qu'il n'y a pas de situation d'urgence. Merci de votre collaboration. Vous pouvez maintenant retourner à vos postes de travail. Attention, attention. Our investigation reveals that no emergency situation exists. Thank you for your cooperation. It is not.
Oh, good. Squelch that alarm. Yeah,
Okay.
please continue.
I'll be quick. Okay, first is a very simple protocol extension. We use the existing BGP extensions such as TLV formats and reduce the development effort. And next is the minimal the network changes. Only the controller and the edge routers require software upgrades and to avoid all devices hardware modifications. And the third one is the scalability. The centralized processing reduce the network flooding and handle the large-scale deployments efficiently. And next we have to talk the BGPRS for the metadata collection is our first step. The BGPRS can support the network topology collection, so it can also be used to extension to the compute metrics. And the metadata path attributed TLV is added as to the BGPRS to carry the compute metrics such as the set performance and the capacity index and the load measurement. These values we don't define the new. We just reuse the format from the last speakers is also from the IDLs group. This draft, and we also allows the multiple sub TLVs for the scalability. Next, the processing is a service metric agents at the edge sites report the metadata to controllers via the BGPRS, ensuring the consistent of data aggregations. And then is a BGPFS for the metadata distributions. And so here we will choose the BGPFS. Think this is a very weak controlling compared with such a netconf. It's influenced but not do not override the routines, so it's minimizing the impact on the existing routing protocols. And for the key extension is here we use the aggregated metric TLV is added to the BGPFS to distribute process the metadata such as the weight aggregates. And this reduces the update frequency and the network overhead. So the controller uses the BGPFS to push the metadata and steering the policies to ingress routers. Then they direct the traffic based on the computer-aware decisions. And here is information forms. It's which there are two options as we discussed. The first is the raw values, the detailed per instance metrics, such as real-time load of the specific service, but it's very high the overhead. And the third one is the second one is aggregate values and summarize the metrics. It's a lower overhead, but sufficient for the steering decisions. So we recommend use the aggregated values, distribute via the BGPSS aggregated metric, the TIV, and show these figures. And next, we will refine the draft upon the comments and the suggestions, and more common suggestions and contribution will be welcome. And it's a very vast presentation, so maybe we can do more discuss at the mail list, and you can refer our slide if you have any questions. We can to further discuss or offline or online. Okay, thank you.
Yeah, thank you. I think Linda's draft provides an example of the way to take this sort of work forward, which is, as you've named it, it's an IDR piece of work, and you should push it there, and it's probably more general than just cats.
Yes.
But putting in some kind of back reference to cats, saying this is the applicability to cats, and then maybe this is the applicability to other things. That's going to be helpful in the long term. But your primary push is to go to IDR and get their work on it.
Yeah. Okay. Thank you.
Oh, sorry, there's somebody in the queue somewhere. But then.
Yeah.
Pong. Yeah.
Have two comments. Maybe one is for slides 2, I think, page 2. So for the third question, you list here what information to be distributed. I'm not sure if you have read the CAS metric document. You may get the answer here. And if you have more suggestions about these points, you can also give more comments on the CAS metric draft, I think. And yeah.
Okay.
Another,
right. Yeah. Okay, first.
Yes, another point, maybe in slides 5 or 6, I'm not sure. You mentioned the maybe not, maybe 6. Okay, I can't find it. But in a slide, you mentioned that there's an advantage of your solution about the large scale. Right, you should pay attention to that. In the charter, CAS now is solve the problem in the single domain. So if you say large scale, is it refers to multi-domain or single domain? You should make it clear. Yeah.
Okay, thank you. I will to consider your comments and to make a contribution to the metric. I think this is very important and about our further works. Okay.
Okay, thank you. Let's move on. I'll be back with you, Geordie.
Would be me in this case. Would be Luis.
Not Geordie, sorry. You look like him.
So hello everybody, this is Luis from Telefonica. I will present this on behalf of my co-authors, Kehan from China Mobile and Jordi from Qualcomm. So the idea is to explore how Alto can be used for in combination with the CATS metric so that we can expose it and use it for several purposes, the steering part, but also the service deployment part. So going a little bit on the background, we have been working on the CATS metrics. Jordi has presented that. So that is fundamental for the decision making about how to where to steer the traffic. So what service instance, what site basically deliver the traffic. But also the compute metrics can serve for the purposes of deploying the service itself. So can have we can have them or can leverage them one step beyond. So where to deploy the different service instances. Alto could be one of the solutions. We consider that Alto could be one of the solutions. There is previous work on it. I will comment right now. And basically, the point here is that Alto is an off-path solution. So basically, could serve for the purposes of passing to external entities, let's say, the information of these metrics, let's say, for the purposes of both steering and service deployment. There is some previous work, as I said. There was some work on metrics, on compute metrics in OPSO. We were bringing there the metrics for the purposes of the covering of this entire service life cycle. So from the service deployment up to the service assurance, service selection, and so on so far. There is a second previous work more focused on Alto, so in the sense that Alto could collect those metrics and expose those metrics to consumers of them. And we will see here some examples of what could be consumers of those metrics. And finally, we have this draft that somehow leverage on the previous work, and the aim of the work is basically covering the deployment phase and the service selection phase. So, So thinking on service deployment, essentially the idea here would be that we could have different Alto servers in both the network domain and the compute domain, or network side and compute side, being these servers the ones interacting with the agents that will be collecting the metrics, and then providing those metrics to an Alto client that could be in a service orchestrator. And this Alto client basically processing those metrics and taking those decisions based on that. One decision will be for service deployment. That is what is depicted here in the figure. So basically, once the Alto client processes all that metrics, is able to pass the information to the cloud controller for performing the service instantiation in the more convenient sites according to that combination of metrics. So basically looking at the healthy or the availability of the number of CPUs, memory, but also information of the network in terms of latency, bandwidth, and so on and so forth. So that would be the case for the service deployment. The case for the service selection would be essentially very similar. So collecting the information from the Alto server, we could inform the Alto client, and the Alto client interact with the path selector in CATS for taking the decision of where to steer the traffic. There are different alternatives. Here in the figure, you can see basically the initial one, but we will consider, we will iterate on that. So basically, it could be more than one approach on this, and yeah, we are essentially working on that fact. So for making Alto, for enabling Alto to do so, there would be the need of providing some extensions. Extensions in the type of cost metrics that are now reported by Alto. So basically, we need to incorporate all the CATS metrics stuff into Alto. You can see that in your left. So basically defining extensions for the metric type, metric level, cost mode, and cost metric adapted to the CATS metric draft. But also we need to extend in terms of the properties so that we can associate to an endpoint in Alto the particular CATS metric. And this is what you can see on your right. So basically, touching the properties with the endpoint address, the metric type, metric level, and metric value. So that extensions will be necessary to Alto for serving the purposes of what we are claiming here. So next steps is we would like to collect feedback from CATS for sure. So check if this makes sense for the working group and if this could be a potential solution, off-path solution in this case, different to the others that we have seen before. If so, if this makes sense and the working group agrees on working in this direction, we will need to figure out where to move the potential extensions to Alto. An option could be OPSO, or maybe we could need to understand what could be the proper home for for standardizing those extensions. And next steps, as said, we will work on the architecture to understand what could be potential options, also to work on the workflows for service selection. We solicit here comments and contributions to improve the document. And that's all from my side. Adrian, thank you.
Thank you. So just for my clarity, this document has no wider applicability than cats. It's totally focused on cats?
Yes.
Right. Good. And at the moment, Alto doesn't really have a home since the working group closed. So I see you're on the agenda for Ops Area Working Group.
Yeah.
And I will try to chase working group chairs and ADs and see what we can conclude about where the right place for Alto work is.
Perfect. Thank you.
Thank you very much. And now we have, I think, yeah, the DNS-based draft. And there we go. Hi, Shang. I have given you control of the slides. But we can't hear you. Still no audio from you, Shang. No. Okay, given that everything is really messed up, is Chanji back? Yes, you are. Great. Yeah, we're going to skip and do Chanji's 2 presentations and then come back to Shang if there's a possibility at the end. If I've got this right, this is the right one.
Yes, that's the right one.
Hooray.
Okay. Good morning, everyone. Can you hear on behalf of the co-authors? This is a draft that being presented last time in Madrid, but I was scheduled for 10 minutes, but only went through for I think 1 or 2 minutes. So this times the draft itself did not get a revision, but I want to give more details about the objectives of why we want to propose this draft for cats. So this is regarding to define a reference model associated with some reference point interfaces, targeting for AI agent communication network. I'll call the acronym ACN. Okay, next. Oh, thank you. Let's see, is it like this? No, should be like this. Oh, yeah, okay, it does work. So this draft is comprised of 2 parts. The first part is give introduction about the AI agent, ACN, and ACN realization models for communication, for network communication part. And after that, I'm going to talk about what is the relationship between the AI agent, ACN, and the cats. So the first two bullets are on the introduction part and the background, and then the next 4 bullets about the CAS related and association with the ACN and AI agent. Okay, so this one, I will just, this is a very hot topic right now, the AI agent communication network, and to give some background of what is the AI agent, and then its instantiation format, either the physical or virtual, and it's very critical, especially in the mobile space. Actually, so far in the 6G discussion, the AI agent, those type of things is very critical and popular there. With the definition or description of the AI agent, and here I just describe what is the ACN or AI agent communication network. You can consider it's like an interconnect network framework tailored to advance the communication among AI agents. Its scope is to reach the global coverage, and then it has some benefit or advantage to satisfy all kind of things like on-demand communication, interactions, all kind of things. So this is just a background for AI agent and ACN. And then for the realization of the ACN, AI agent communication network, there are 3 communication models. The pictures I just quoted from our company's white paper, AI Agent Communication Network, published last July, the year of 2024. In that white paper, it specified 3 different network communication models. One, the static intra-domain, and the second one is the static inter-domain, and then the final one is the dynamic multi-domain, the ACN. For intra-domain ACN is a model for AI agent residing within a single administrative domain. For the inter-domain ACN, basically for AI agent that reside across multiple administrative domains. And then for the dynamic multi-domain part is a model for AI agent that may dynamically form a networking group to handle a temporarily generated task. So it's like formed and then to work on some task and then close at the end. So it's like dynamic part. So far, this is just like a background about AI agent, ACN, and ACN realization. So when we look at further about, okay, so what is the connection or relationship between the AI agent? Should I answer the question right now or just?
I think keep going.
Okay. So here is like, what is the relationship? Why I want to introduce the AI agent ACN here in the CAS? Because for the AI agent, okay, or they have dramatic variations among the demands, data processing tasks, and the capabilities of AI agents. Here I give two examples. One is like the computer power of the lightweight terminal, the smartphone. Is difficult or is kind of facing challenge to handle locally the complex computation tasks with more than billions of parameters. And then other one is the challenge of real-time responsiveness if complex tasks are delegated to more powerful instances deployed remotely in clouds. So this is, well, of course, there are more cases from 3GPP, like ambient IoT, integrated sensing, those type of things. So when we look at these cases, and then we know it's very familiar for our CAS community, this is something needs CAS optimization. Well, I remember at the very beginning about why we introduced the working group of CAS, and then this is just like, okay, close may not be best, maybe the remote one might provide a better capability, those type of things. So when we look at AI agent and associated with ACN AI agent communication network, and they say, okay, we know this type of things need CAS optimization. Okay, in order to proceed here, I'll just look at the CAS. What CAS has right now? CAS have 2 metrics. One is the network, the other is compute. And then, but for AI agent, AI agent sort of is like an application client that's going to reside on some physical one, or it can itself be the physical format. In that case, the network metric and compute metric cannot fully reflect what AI agent might have. So in this draft, we define a third metric. It's the AI agent metrics. So well, here, just to give some examples of what might be comprised, what might be comprised of the AI agent matrix. It's like a functionality, capabilities, the model types, a number of parameters of a model, and some other policies, and etc. So here, just remember, there are two existing network metrics, and the one is the new one defined as AI agent matrix. So when we look at for the existing CAS metrics, and here on the green part is existing, so it's applied or it's targeted toward the traffic steering and the network layer, might be achieved via the network protocol extension. But for AI agent, it's generated for the overlay exchange among application clients that are served as AI agent things. So this subject to signaling path over network protocols. So here we define for the AI agent matrix that are between among AI agents and above the network and the transport layer. So it's like a network protocol stack. So it's like for the two bottom one is for existing, the compute and network, and the top one is for AI agent things. So this picture might be better to explain what will be like here. If we ignore the left part, only look at from the cloud about the left from the right side, it's the traditional or existing CATs. It comprised of CPS, the path selector, and the C-NMA, the network metric agent, SMA, and also the interactions among them. But when we introduce the AI agent here are using the user equipment that will be run there. It can also be deployed on terminal equipment toward the left-hand side. Since this is like I'm using a mobile space, because I put that's why I put AN as access network. But the things, the whole reference model is not restricted to the mobile space. So here, when you look at this one, so is this the thing, the reference model? The whole thing. So when we extend the CAT, it's going to include both the existing CATs and with some extensions that's going to be applied for AI agent part. So and then in that case, it's going to introduce interactions between different entities, the existing CAS entities, and some more entities that will be introduced by the draft here. So this is the reference model, and all you can consider it like extended the framework of the current CATs. Okay, this is the reference model we have put in the draft. But this is just like, okay, when we want to do some work, so how to define the reference model. So remember that picture, and we want to see, okay, the reference model proposed so far is like a producer and a consumer model. It's going to involve a lot of things, like a reference point and interfaces. For example, between the existing one, the CPS, and the C-NMA, we defined the RP, the reference point, as a PS and NMA with reference interface as a C1 and C2 that are associated in the scope of the RP, the reference point, PS, and NMA. Okay, the bottom one is the RP between the AIA, the AI agent thing and the CPS, and a bunch of consideration when we try to define the reference model, what should be considered like a service model reference points, signaling messages, like a definition parameters, and the type of exchange messages, like example, like network compute and AI agent metrics, and also signaling and the management procedures, overlay base, or communication channel and implementation. So far, when you look at the whole things, the first part is to give the background and introduction of the AI agent, ACN, and the realization model of the AI of the ACN. And after that, we describe the relationship between the ACN, AI agent, ACN, and the CATs, and how the CATs may be extended to accommodate one or third matrix. That is AI agent matrix that can be used to complement the whole existing CATs the framework or but we call the reference model maybe. And I'll define a different like the reference point and the interface of the ACN things and give the description of the part. Okay, so I'm sorry. Yeah, it should be this one. Yeah, so this is the summary about the things. And then we believe so far, or with the imminent of the 6G discussion there, and with the important popularity of the AI agent and AI agent communication network, and also with its relationship or connection with the CATS-like optimization requirement. So we believe we should extend CATS framework, or we can define a reference model for CATS that can accommodate more things, basically the ASIN things. Thank you.
Right, we've got a lovely long queue. First is Linda, please.
Hi, thank you for this presentation. I'm curious, this ACN, do you have a summary of the key differences between ACN and today's network? Like specifically for the network, like for example, the volume, you did mention billions of data exchange. Is that like a bursting traffic, or is it scheduled traffic, or is that key differences? Do you have like a summary of them?
Here, well, just like the ASIN is just is a global network framework used to help the communication among AI agents. It has some demands, like on-demand communication. Remember the realization model, they're a dynamic part. And then also it has need interactions and collaborations, security, controllability, and all the deployment model of kind of things. In terms of the traffic or the volume things, at this moment, there is no specific requirement or investigation or what will be like the KPI metrics will be achieved there is still being explored in the field. There's not like a mature technology, it's an existing one. No, there's no specific things like that.
Okay, thank you.
Chong.
Hello, Johnny from Huawei. So I'm really interested in this document, but my question is, do you see any new metrics should be standardized regarding the AI agent? Because I guess we can use the layer 2 a metric for it, even for the AI agent. Yep.
Yes, I do see here because if you look at compute and network, we know bandwidth, delay, all kind of things, and compute, the GPU, CPU, memory, those type of things. It's more very objective things. And for AI agent, the thing is it's like application. It's not the suppose you get the server and you have the hardware spec, and most of the time you have this the predetermined capacities, although it might have some runtime variation. But for AI agent, if it instantiated as a virtual format, it will have a different parameters. But it does depend on the models, the AI models, and then that going to like a number of parameters, all kind of things. So I consider this one, the AI agent, it's going to have the objective one, and sometimes it might have subjective. But subjective one, that need further consideration. So I do see a necessity to consider extension for the metrics part.
Okay, Grumpy.
Okay, thank you.
Daniel Huang, ZTE. Thank you for your presentation. Actually, I've read the white paper of Agent Communication Network. It's a perfect work, I think. I believe CAS framework will help ACN in terms of AI agent service traffic steering. But when you are talking about the AI agent metrics that you want to extend in CAS working group, I'm a little bit confused because, as you mentioned, the AI agent metrics is actually application level metrics. So my understanding is that the AI agent metrics could be aligned between CAS framework and the ACN framework. So I would suggest the CAS matrix remains as it is, as in Kehan's documents. You can put standalone jobs to work or some other sections to materials to the alignment between the ACN framework and CAS framework to see what could be done to fill the gap.
Okay, yeah, good suggestion. Yeah, thank you.
And lastly, Lewis.
Yes, Luis from Telefónica. You have insisted that through the presentation
Can you
on
close to the.
No, sorry. You have commented through the presentation on the agent word, but I was wondering if the data that support the processing of the agent is also considered here. So basically the steering of the data through the agent and so on and so forth. So I missed somehow the data component, the data that will be processed by the agent and so on.
The data component,
the data that the agent will consume or will
oh no, that one is like it's more kind of subjective. The so far is like the CAS domain here. We try to make it objective things. So it's like a compute metric, network metric, the kind of very objective things. And then if we consider the data traffic, that is so dynamic. If you try to introduce that things, I cannot view how you're going to fit into the existing metric or the extension metric for AI agent things. Yeah.
Okay. Thank you.
Yeah.
Sorry, Jordi, we had to close that. Let me see if I can move you on to your next slide. I just want to say while I'm doing that at the moment, CATS is not chartered to look at AI agents. It is an interesting problem, and it is potentially an extension of CATS, but we need to be, kind of careful.
Sure.
So I would suggest keep doing the work, keep talking to all the other AI agent groups. I think there are like 6 side meetings this time round on AI agents.
Okay.
There's a lot of interest. Feel out those people, talk to them, and see what you can arrive at.
Okay, sure. Thank you. Okay, this is the second draft, actually in one series. The first, the one I just presented is regarding the extensibility of the CATS. Now, this is regarding the applicability of CATS framework. Okay, I'm Tianji on behalf of all the co-authors. Okay. This draft also include 2 parts. The first part is just going through the working group drafts of the CATS working group, like framework, use case, requirements, and metrics. And then after that, I'm going to discuss the CATS framework and its applicability to some noteworthy scenarios. One is the ACN I just presented, and the other 2 is the 5G edge enhancement, and the third one is the O-RAN middle haul. For all the 3 scenarios, there are individual drafts to give all the details, and then what their connection or relationship with the CATS already. They have all the 3 have been submitted to the CATS working group, so there are existing drafts. Okay, when we look at CATS working group right now, there are 3 official drafts. 1 use case requirements, 1 metrics, and 1 framework. For the use case, it provides a list of typical scenarios and outline the requirements. And the second one, metrics, is define a set of metrics. And then third one is framework. When we look at all the 3 things, and the framework itself, it propose and define a generic or general architecture. Okay. That can be, we believe that can be applied, or maybe that one among all the 3, right? That actually is the best suitable to explore the applicability of CATS technologies. Like if you look at the use case requirements, is there already? Actually, it's distilled or abstract. It has abstract something based on use cases. And the metrics is level 1, level 2, all kind of things. But the framework is a generic architecture. It can be applied And then it's very useful. It's a general architecture in encompassing various building blocks and realizing the CAS CP control plane and data planes. And also it's very good for achieving objectives of CAS optimization. Here I use a quotation mark because CAS optimization is has been fully defined or explained in the draft. So out of the three, we believe the CAS framework is the best suitable to pursue the applicability of the CAS work. This one is just a recap about the CAS framework for the CAS community. It's just a very it's a piece of cake, very trivial information, and some functional elements in the CP and the DP. Like the CP, it has a CAS PS, CAS SMA, and the CAS NMA. On the data path, it has CAS forwarder and the CAS traffic classifier. And in the CAS framework, it talks about the deployment of CAS functional elements. But in the draft, it makes no assumption of the model, like a distributed model, a centralized model, or hybrid model things. And also it said, since there's no assumption of the model, and it said may only reflect the preferences and the policies of the CAS service providers. So in this scenario or in this context, we, the authors, believe it bodes well for drafting a document to illustrate the applicability of the CAS framework to some noteworthy scenarios. Well, in this draft, we used the ACN, the 5G Edge, and the O-RAN middleware to demonstrate, the applicability of the CAS framework. Yeah, this is a recap. Thank you for the group chair to arrange, these two drafts in the good order. So I will just skip this one, this AI agent, ACN, and the realization part. Okay, and then for this one, this is the first scenario of the applicability of the framework to ACN. The left picture has already presented in the previous one. It's just the existing CAS functional elements with the extension of the ACN. That is the left. This is like from the point, very high level description. And then for the right picture, it's just to see, how the CAS framework with the extension can be applied for the ACN things. And then in the right picture, it has all the existing CAS functional elements and the framework, the part like like service side, service instances, and the CAS functional elements like CPS, CMA, and the CSMA, plus the extension, because this is the scenario for the ACN. So it has AI agent and associated AI agent called AMA, AI agent metric AMA. So just to try to follow the naming convention of the current CAS, like SMA, NMA, and here called AMA. And for AMA, it can be co-located with AI agent itself, or can be deployed on the service side. So they make no difference from existing NMA or SMA, the deployment of NMA or SMA things. So look at this picture, and it's a perfect the fit to talk for the applicability of the CAS framework to ACN. The next scenario is the 5G Edge. We have a draft that was last year to describe about the 5G Edge. So since this is edge computing, you just consider is something service to be hosted closer to any device, the access point of attachment to reduce the end-to-end latency and the load on the TN or transport network part. The picture just gave a very brief diagram of overview of the 5G system, along with the edge computing of 5G Edge. The UPF in the picture you can consider is just like it's like a router, but it for sure has a lot of functionality features beyond that part. But in this scenario or in this context, consider it like a router here. And then we have a centralized UPF in the middle. I don't know, is the PowerPoint here? No? Oh, yeah. Yeah, here. Here is the central part, and then this is the local access, the local PSA things, and then this is the DN networks, which has quite a few EAS or edge application server residing inside the DN. For those EAS, they can be accessed either through the centralized path or through the local path. In the 5G edge, that is a feature that has been standardized in 3GPP SA2. It considers the network matrix, here, consider network matrix out of the N6 interface here, use the N6 delay over TN to consider for the optimization to select the optimized UPF that has the least latency toward the EAS on this side. And also for the compute part, although the 3GPP did investigate during the study phase to say, okay, whether can introduce that one, but there's no further action. That one has been delayed. But here I do put here just say, okay, the EAS, the load, how it can be considered for future things. So for the 5G edge, they have like the different, but this is more related to the architecture of the 5G, but there's the mapping from the 5G functional or NF network functions, plus some procedures here that can be mapped to the CPS, CNMA, and also the cat forwarder, those type of things. So this is, although it's not a perfect, but it's very closely it's very close example for the applicability of cat framework. The next one is applicability of framework to O-RAN middle haul. First section is regarding the background. So you can just make it very simple. O-RAN split the radio functions into RU, DU, and the CU. The middle haul is between the DU and the CU. Okay, distributed unit and central unit that is connected through whatever transport network like IP, MPLS aggregation. Even the native is okay. So the middle haul traffic steering can dynamically select the CU instances based on both the CAT's compute and the network matrix here. So this is the background. All the details are in the CAT's. There's one draft talking about these things. So for the applicability of the framework to O-RAN middle haul here. So for this picture, for the CNMA, CSMA, this is just the traditional CATs within the CAT framework. And also for the CPS, and in O-RAN, there are TNM, is a TN manager that can decide to which CU or its service instance to deliver the DU traffic. Remember the radio unit, the radio function is split into RU, DU, and the CU, the traffic, the middle haul. The traffic of the middle haul is to steer from the DU and the CU here. And then the CPS or TNM can make this decision. And the TNE, the TN element, transport network element, is can act as the PE node. It's just similar to a CAT forward. Okay. So for all the three cases here, remember at the beginning, I said, okay, the authors investigate the current working group drafts of CATs, the use case requirements, metrics, and the CAT framework. When we look at all the things and digested what has been standardized in the draft, and we think the CAT framework builds the most suitable information or contents or whatever things, because it defines a generic architecture that can be applied. It has the best way to proceed with the applicability of CAT's work. So that's why we use this one, the CAT framework, and apply this to some noteworthy scenarios. Yeah, so I think that is things, and just try to see the working group has interest to pursue an applicability draft applying the CAT framework. Thank you.
Chen Yang, if you can be really quick.
Okay, thank you very much. Just a simple question. Please go back to page 6. Oh, yeah, this is Mel from DT. Yes, just a simple question. Do you think the AI agent is a kind of the service instance, or is quite different things?
it's going to provide the service, but the thing here is like more the application, the layer part. It's different from the service in the context of CAS right now, because in the service in the CAS, it's more like a service instance associated with some service metrics. And then that is more like a hardware spec, all kind of things, although it does bear on the runtime information. So it's different from in the context of CAS, it's different. Yeah.
Okay,
thank
thank
you.
you. Thank you, Chen Yu. We're going to give Shang another attempt at this. I'm aware that it's past, but also that there was a fire alarm. If you need to go now, if you need to leave the room, please do it quietly, and we'll just spend 5 minutes on this.
Okay, so Chair, can you hear my voice now?
Yes, it's working.
Okay, good, great. Okay, so I will quickly present this document, and so this is the 01 version of our draft DNS-based service discovery for computing over traffic steering, and so this is Xiangliu from Proton Laboratory. Okay, so first of all, I'd like to briefly recap this document, and the motivation of this document is that a key requirement of the CAS framework is to provide a discovery and resolving method for the mapping of a service identifier to a specific address. So it is natural to utilize the DNSSD mechanism, which is specified in RFC 6763, and so the scope of this document is focus on the service registration and the discovery mechanisms, and did not affect the routing traffic steering process in CAS. And so in this regard, the main methodology utilized in these documents is to provide a service registration and the discovery mechanism using the DNSSD, and so to facilitate service instance resolution based on client-specific requirements, and it includes several different phases. For example, the first one is to define a service name and the service instance name, and the second is to specify the service advertisements mechanism. The third one is to specify the service instance capabilities or parameters advertisements mechanism, and the last one is to specify the service instance resolution mechanism. And as suggested by the chair Adrian and some other experts' suggestion, we try to compose a diagram to show how the service discovery mechanism integrates with the CAS framework, as though it is still a high-level diagram. As you can see from the diagram, we we imagine that there's two different functional entities, which the first one is service registry, and it is located in the management plan of the CAS framework, and it is mainly used to store the registration information of the CAS service instance, including the service name, the IP address, and the port numbers, and the service metrics, and something like that. And the other thing is the service resolver, which can be implemented in the management plan of the CAS framework, and can be implemented in the client side as well. And it is used to resolve the service instance IP address and and the port number according to the service name, which is derived from the specific service request from the clients. So in this regard, the clients send the service request to the resolver, and the resolver can resolve the service instance name from the service registry, and the service instance has registered in the service registry. So this is basically the fundamental architecture of this framework. Okay, so during the last IETF meetings, there are some issues raised by the the working group. For example, in the beginning, we try to use TXT records to store the parameters of the service. So it is recommended to use discrete resource record type. So in this version, we defined a new type of resource records, and some other very detailed issues raised by the working group, and I will not read it line by line. So to save time, we just briefly summarize the updates since the last IETF meeting. We replaced the TXT record with a new defined resource record type, which is CAS parameters. And we add some discussion about nameplation, avoiding requirements, and we add some discussion about the DNS security mechanisms, like, for example, the transaction authentication. And we also discussed the performance considerations for the DNS ST mechanisms. So about the next step, there are some issues that are not being addressed yet. So we'd like to compose a more detailed framework and the protocol specification. So basically, how service discovery and the resolution mechanism, maybe based on DNSSD, integrate with the CAS framework should be more detailed and discussed in the future. And some other detailed implementation considerations should be also carefully addressed. For example, we need to consider how to revoke a service update request when errors or other issues happened, and we also need to discuss some implementation details, like the update frequency of service information, the capacity of the service registry, and the propagation delay of service updates, especially for the wide area networking scenario, which is a basically the typical scenario for the CAS framework. So this is all. Thank you very much.
Thank you for being quick. I need to remind us of two things. One is CATS is not going to do DNS work, so it's fine to be raising and discussing this here, but we are going to need to find a proper home for it. There is a related or a similar piece of work, a draft from Jim Mosley of Infoblock, that has just been presented in dispatch at the same time as we were meeting, which is a bit annoying. And that's looking at AI agent discovery. And the conclusion of the dispatch meeting was that it's a sufficiently significant piece of work that it should go to a BOF. So I suggest you find Jim and talk to him and see whether you've got common approaches that you can be using. You know, you don't have to, it doesn't have to be the same data, but it would be really convenient if it was using the same DNS structures to do similar discovery. And then if that happens, there will be a clear place to do it, because if there's a BOF and a working group, that'll be where you can take your work.
Okay, it's good to know. Thank you. Thank you, Adrian.
I'll drop you an email about that, just to put you together. Okay, thank you, everybody. Thank you for running over a couple of minutes. And don't forget the mailing list.
Bye bye, guys.